So for here, again, like I said, what we're doing is we have these three different expressions. We have negative 5x plus the 8y minus 3 plus 7z. Expression B is 6x minus 2y plus 4z. And expression C is 12w minus 8x plus 2y plus 9 minus z. So what we're doing is we're identifying which expressions we're talking about in these situations. So for problem number 1, I want to know which expression has a 2 for a coefficient. So remember, for a coefficient, that means that we are trying to identify the value that is attached to our variable. We're identifying the value that is attached to our variable. Okay, so I'm going to even write that down. I'm going to highlight. When I talk about coefficient, I'm talking about attached. It is attached to the variable. So I am looking for something that says positive 2, because it's just a 2, and a variable. So let's take a look at the first expression. What is the coefficient for the first term here? What's this coefficient, Isaiah? Not just 5, but negative 5. Negative 5. What about here? Is this a coefficient? Yes. It is a coefficient because it is attached to a variable, so that's a positive 8. Is this a coefficient? No. Because is it attached to anything? No. What about here? Is that a coefficient? Yeah, it's attached, but is that a positive 2? No. Okay, so let's look at expression B. Is that a coefficient? Is it a 2? No. Is that a coefficient? Is it a 2? Is it a positive 2? No. See, that's a negative 2. The fact that it says minus 2y, that negative 2 is not what we're looking for. We're looking for a positive 2. We want a positive 2. I'm even going to write this down, that we want it to say plus. Okay, so that's not going to work. This one's not going to work. It is a coefficient, but it's not a positive 2. So let's take a look at C. Does C have a positive 2 for a coefficient?
Yes.
Yes. What variable is it attached to?
2y.
The 2y, right? The positive 2y. So right here, this is what's going to work for us, that positive 2y. Okay? So expression C is our answer. Expression C has what we're looking for. All right, for problem number 2, which expression has no constants? No constants. So if I want to talk about a constant, remember, a constant is a number. It's a number without a variable. Okay, it's a number that does not have a variable at all with it. So do we have any expressions up here that have no constants? So if it's no constant, it means that there are only variables with their numbers. Diana? B, right? Yeah, we've got a 6, but that's a coefficient. It's attached to a variable. That minus 2 is attached to a variable. That plus 4 is attached to a variable. We don't have any numbers that have no variables attached. Okay, so problem B, there are no constants. For problem 3, which expression has 4 terms? 4 terms. Now remember, terms are separated by what 2 operations? What 2 operations will separate a term? What's one of the operations that can separate a term? Or what operation would that be? Minus. And what's the other operation, Angel? Addition. So terms are separated by plus and minus signs. Terms are separated by plus signs and minus signs. So we're looking for 4 terms, 4 things that are separated. What's the only expression up here that has 4 terms, guys? Which one? Gavin, what do you think, honey? Which one up here has only 4 terms in it? A. Okay, A is the only one that has 4 terms, right? We've got a negative 5x. That's our first term. We have a positive 8y. That's our second term. We have a negative 3. That's our third term. And then we have a positive 7z. That's our fourth term. Okay, so these are the split ups of our terms. How many terms does B have? How many terms does B have, Isaiah? 3. How many terms does C have? How many terms does the expression C have, Mia? 5. Okay, so only expression A has 4 terms. All right, let's focus now on expression A. For expression A, what's the constant? What number up here is the constant? So remember, the constant is a number that does not have a variable. A number without a variable. Gavin? Not just 3, but what's the sign in front of it? Negative 3. So remember, we got to include the sign. You can't just say the number. You got to include the sign. If it was a plus sign, then you would say it's positive. But the fact that it's a minus 3, we're including that negative in there, that minus sign as it. So it's a negative 3. Okay, let's go to expression C. What is the coefficient of the last term? The coefficient of the last term. So I want to focus on the very last term. What's my last term? Ilani? My last term. The Z, right? The Z, this is my last term here. What's the coefficient of it? Not 9, the coefficient. What number is attached to it? Anasia? An invisible 1, but not just an invisible 1, it's an invisible negative 1, right? There's an invisible negative 1. I'm going to put that right here. So remember, you have invisible 1s that are in front of variables. If a coefficient isn't written, then we write an invisible 1. So, and since there's a minus sign in front of it, it's a negative 1. Negative 1 is the coefficient of our very last term. Okay, and then for problem 6, let's go ahead and substitute these values in for our last expression. So instead of saying 12 times W, we're going to say 12 times 0, right? We're going to say 12 times 0. And instead of saying minus 8x, we're going to say minus 8 times, what's our x? 3. So I'm going to substitute the x value with a 3. So it's minus 8 times 3. And then I see it says plus 2y. So I'm going to do plus 2 times what? The negative 2, right? The y is a negative 2. So we're going to do 2 times negative 2. And then it says plus 9. Well, there's nothing that I'm changing about that one, so just plus 9. And then it says minus z. So I'm going to put minus, and then I'm going to subtract my z. What's my z? And negative 5. So I'm going to put minus negative 5. Okay, so all I've done is I've substituted those numbers that I just highlighted in for the variables that they were in replace of. Now, remember the wonderful thing of those calculators of yours, they will calculate order of operations for you. All you have to do is type it exactly as you see it. So if I type it, I'm going to type 12 times 0 minus 8 times 3 plus 2 times negative 2 plus 9 minus negative 5 and hit enter. What do we get, guys? Negative 14. You're going to get negative 14 as your answer. Okay, so that's just reviewing again over what you did with the GIM kit. Overall, your GIM kit scores looked good. Majority of you were able to get a proficient score of a 70 or higher. So I'm very pleased with that. I'm ready for us to move on to our simplifying process. So what we're doing here is we are now going to simplify. That's our learning target. Our learning target is I can simplify expressions by combining like terms. So like terms, by definition, what we mean by like terms are terms that have a common variable and those variables are raised to the same power, the exponent, that little number that goes up in the top right corner if one exists. So we're talking about our like terms. So like terms are going to have a common variable. That's the important thing to make sure you know. Like terms are going to have a common variable and they're going to have the same exponent. That variable will have a same exponent if there is an exponent present. So what I want to do here is I'm going to start with the very first number that I see, or the first term that I see positioned up here. And I'm going to go ahead and try and identify a like term to it. So this is a constant. This 7, I'm going to highlight it in green because I know that it's a constant. Do I have any more constants up here? Yes or no? Some of you are saying yes, some of you are saying no. No. Well, is this a constant? No. What's a constant again? A constant is a number without a variable. So is this a constant? No. What about this one? No. What about this one? No. Yes. It's just a number, isn't it? Is there a variable with it? No. So is this a constant? Yes. So I'm going to highlight it in green. That's a constant. What about this one? 0.6y, is that a constant? No. What about negative 1/2 x? Is that a constant? No. Okay, so I have like terms with these two constants. So I'm going to write that down. That's 7 and negative 8 are like terms. Because even though they don't have a variable, that's what makes them a like term. They aren't attached to a variable. They are both constants. That's what makes them alike. They are both constant values. Okay, so let's take a look at our next term here. We've got a 4x. I'm going to go ahead and highlight that one in pink. So this one does have a variable, and the variable is an x. So in order for it to have a like term, it has to have another partner or several partners that also have just an x. It could be any coefficient. Doesn't have to be another 4. It could be any coefficient. It just has to have the same variable. Are there any other x's up here? Yeah. Which one? The negative 1/2. That negative 1/2 is also a like term of x. Okay, so they are going to be considered like terms. So I'm going to write that down. 4x and negative 1/2 x are like terms because they both have the same x variable. They are both x. Okay, so we still have some stuff up here that we haven't highlighted. Let's go and check them out. We've got a negative 2y. I'm going to highlight that one in blue. And the reason I'm going to highlight in blue is because I know it's not the same variable as x. It's a y variable, so I don't want to highlight it the same color as my x. I want to choose something different. So y. Do I have other y's up here? Yeah, right? 0.6y. Even though one of them is an integer and one of them is a rational number, that's okay. So I'm still going to highlight them because they both have a variable of a y. That's what makes them a like term. It's not focusing on the number, it's focusing on the variable. So negative 2y and 0.6y are like terms. And again, what makes them like terms is because they both are in terms of y. So knowing what like terms there are, it helps us to be able to simplify expressions because we can combine like terms together. If you know you have apples over here and apples over there, you can combine your apples together to have a combination of one pile, right? If you're trying to, has anybody ever separated their toys out when you were younger? Did you ever separate your toys out and go, okay, oh, I'm going to put all my Barbies together over here and all my G.I. Joes over here, or whatever toy that you had. You kind of separated, kept them separate. Maybe they were in timeout. It's kind of the same thing. You want to pile all of your same stuff together in one pile all of your other things in another pile. You want to put what you can combine together. It's kind of like what you did when you were younger and separating toys out, okay? So here, I've got 4x, and I've also got 3x, and I want to combine them together. So when we're combining like terms, girls, when we're combining our like terms, what we're focusing on is the coefficient. If I say I have 4 x's and then I'm adding 3 x's, how many x's do I have? If I've got 4 x's and I'm combining it with 3 x's, how many x's am I going to have, Angel? 7 x's. It's kind of like pretend it's not x's. I've got 4 cookies on one plate and I've got 3 cookies on another plate. If I put all my cookies on the same plate, I've got 7 cookies. It's the same thing, but this time it's variables. So what you're doing is you're just combining the coefficients. I'm just focusing on that coefficient, and I'm focusing on the fact that it says plus the 3. Okay, so I'm really just doing 4 plus the 3, and the x is just along for the ride. That's it. So when I combine 4 and 3 together, I get 7. That means I have 7x as my final answer. And again, if you need to see it visually, 4x, I'm just going to draw out 4 x's. 1, 2, 3, 4. And I'm going to add it with 3 more x's. So I'm going to add 3 more x's on. 1, 2, 3. And then if I count all the x's together, that's 7 x's. Okay, let's take a look at problem number 2. With problem number 2, I don't just have x terms, I also have a constant, right? So the first thing I want to do is I'm going to rewrite my statement so that my like terms are side by side. So that means I need to identify my like terms. I've got a like term that's a 3x. I also have a like term that is a minus 8x. Now this is the most important part. You must make sure that you are including the sign with the term. You have to bring the sign with you, because the biggest mistake students make is they go, oh, I'm going to do 3x plus that 8x. But the 8x is not being added. It says it's a minus 8x. So you need to make sure you bring it with you as is. We can rewrite this as 3x minus 8x. And notice my plus 6 doesn't have a like term with it. So I'm just going to circle it in green, and I'm going to rewrite it behind everything. I'm going to put plus 6 right behind it. Okay? Ashir, make sure you're focusing up here, not on your calculator. All right, so now what I'm going to do is I'm going to do 3x minus 8x. Now, let me warn you. You cannot type a variable into your calculator. If you try, it's going to give you a 0 for your answer no matter what. If we do 3 minus 8, is that going to be 0? No. No. But let me show you. If you try to type 3x, if I type 3 and an x, and I try to do minus 8 and an x, it's going to give me 0 no matter what. It's always going to give you 0 because those x variables, those are not used for calculation. They're used for graphing purposes or table purposes. We will never use those variables in the calculator. Okay? So do not type variables into your calculator. All you're doing here is you're focusing on doing 3 minus 8. What is 3 minus 8? Not 5. Negative 5. So that means 3x minus 8x is negative 5x. Just don't forget to attach your variable. And make sure you're paying attention. Isaiah, sit up. Okay, now I did not have a like term with this 6, so it just comes down as a plus 6. And that is my final answer, negative 5x plus 6. I cannot combine those together because they are not like terms. Again, you can only combine like terms together. So that's as simplified as it gets. You're not getting a number answer. You're not solving anything. You're just simplifying it as far as you possibly can go. Let's take a look at problem 3. So for problem 3, we've got several variables here, and you probably are wondering which variable do you start with? Well, guys, which variable comes first in the alphabet, a y or an x? X. It's called XYZ, not YXZ, right? In the alphabet, X comes before Y. You want to go alphabetically. You want to make sure when you're working this out, you work it out alphabetically. Okay, so we're going to start with the X first. So is this 4X a positive or a negative? Positive. Positive. I know it's positive because it says plus 4, right? Plus 4X. What's a like term with that one? Somebody raise their hand and tell me what up here is the like term, Justin?
2x.
The positive 2x. So I'm going to put a box around positive 2x. Those are two like terms. So I'm going to rewrite it as 4x plus 2x. What is 4x plus 2x? Brian? 6x. Good. All right, so I've simplified the x's. Am I done? No, I still have the y's I need to focus on. So I've got a negative 2y. I'm going to circle that one in blue. I've got a negative 2y. Do I have a like term with it?
No.
Do I have any other y's? Yeah, Aisha? 7y. Is it positive or negative? Positive. So I have a positive 7y. So I've got negative 2y plus 7y. I need to go ahead and simplify that. So what is negative 2y plus 7y going to be? Basically, in your calculator, you could do negative 2 plus 7. What's negative 2 plus 7? 5. Okay, so now I'm going to write 5y, but something's missing here. What do you think I should put here since it's a positive? What do you think? A plus sign. I have to write a plus sign here. So remember earlier in this unit, I told you guys, hey, we're writing those positive signs. This is why. You got to get used to writing positive signs for positive answers because sometimes it might be an operation that goes in between it. If it's a positive answer, then that means it's a plus sign in between. If it's a negative answer, that makes it a minus sign in between. Okay, and that's our final answer. Let's take a look at number 4. We have n minus 4 minus 9n plus 7. So let's start with the variables. We have an n, but it doesn't have a coefficient written there. What do I automatically know is there if it's not written? A what? A 1. A 1 is written there, so I'm going to put a little 1 right there. What's a like term with that one? I've got a 1n. What's the like term with it in Asia? Not just 9n. Negative 9n. Don't forget the sign, guys. That's important. If you don't remember the sign, you're going to get it wrong. Minus 9n. That goes along with it. So we're going to put 1n minus 9n. 1 minus 9. If we do 1 minus 9, we get negative 8. So this becomes negative 8n. Negative 8n. Okay, now I've got my constants. I've got, what is this? Negative 4. Good. It's a negative 4 and a positive 7. A negative 4 and a positive 7. So when I combine those together, negative 4 plus 7 gives me 3. So am I just going to write 3?
No.
What am I going to write? Ashley? Am I just going to write 3? What do I need to write in front of it? Huh? Positive. Plus sign. It's a positive 3. I got to write the positive sign. I got to write that plus sign. Make sure you're writing this down. I shouldn't have to be telling you guys to write the stuff down. This is your notes. So our answer is negative 8n plus 3. All right, let's try this one. Let's start with our x. We have a negative 3x. Who can raise their hand and tell me what is the like term with negative 3x? It's always the same people raising their hands. Gavin, go ahead and tell me, honey. Positive 15x. Okay, so we have negative 3x plus 15x. We're going to combine that together. Negative 3 plus 15 comes out to 12x. Then I've got my constants. I've got a negative 9 and a negative 2. Negative 9 minus 2 is going to come out to a negative 11. So when I write it, that negative 11 now looks like it's just minus 11. That's my final answer. Okay, if we look at problem 6, we've got 7y minus 11x plus 12 minus 8y plus 11x. We're going to start with our x's first. So I have a negative 11x. I know it's a negative because of the minus sign in front. And I have a positive 11x. I know it's positive because of the plus sign in front of it. Now, when I do negative 11 plus a positive 11, what is that going to give me? 0. It's 0. So if I write 0x, do you think I need to write the x anymore?
No.
Nope, I don't need to write it anymore because it's a 0. All right, let's move to our y's. We have a 7y minus 8y. 7y minus 8y. That's going to come out to a negative 1y. Now, do I have to write the 1? No. Do I have to write the negative? Yes. So I could just write negative y. And now I have a positive 12. Do I have another constant to go with it?
No.
No. So it's just going to be written right behind as a positive 12. And there's my final answer. Negative y plus 12. You guys have a couple of minutes. Go and try the ones on the back on your own, please. And as you're working through it, let me just tell you for tomorrow for your digital day assignment is loaded onto Google Classroom already. I like to load it ahead of time for you guys. It is a Delta Math assignment. It is a Delta Math just focusing on combining like terms. There's one set that is a guided practice, so they're going to say, hey, drag one like term to another like term, and then just focus on combining that. Then drag another like term to another like term, combine that, and then keep doing it until it's simplified all the way. Then the other one is you doing it on your own. Okay? Again, here's the solution to those last 4 problems that you tried on your own. Just don't forget, guys, a lot of people forget that when you just see an x, remember there's an invisible 1 attached to it. It's really a 1x. If you see a minus x, it's really a negative 1x, or any kind of variable. Minus any variable, that means it's a minus 1. You have that invisible 1 there. Okay?